Hi folks, so today what we're going to be learning about is the area underneath conics, okay? And specifically the area in conics we're actually going to be focusing on is the area on an ellipse, okay? First of all, an ellipse, guys, is kind of like what looks like a kind of an egg-like shape, okay? Or an oval-like shape where basically you have a circle and it's like you pull the circle and you elongated it, okay? And what we're going to be learning about is where an ellipse actually comes from. So if we look here on the SolidWorks model, we can see here we have a cone, okay, and it's an upright cone, okay, where it's obviously the base of the cone is a circle, and when we look straight at the cone we know that we see a triangle, and when we look at the cone from the top view we're going to see a circle, okay. And obviously then, and I'll just go into my 3D view here, we have a cone here, and obviously we can see that the vertical plane behind it and then the horizontal plane underneath it. So what we're actually going to be learning about is how an ellipse is created. So I'm just going to go back to my right view there and going to take you in here. And an ellipse is created when a cone has been sliced at an angle. So what I'm going to do is I'm going to put in a little cutting plane here, a section view, okay? And what I'm actually going to do is I'm going to rotate that section view, and you can see there it's kind of taking a little bit of the cone away, but I'll pull it back off. So on that section view there, okay, I've basically got this kind of green line here which is at an angle, okay, and I can change that angle to suit myself, it doesn't matter, okay, but what's important to note is that the angle of the green line is different to the angle of the cone, okay. So now what I'm going to do is I'm going to bring that cutting line, it's like I'm taking a slice and I'm slicing the cone away from the top. So you can see here it's starting to disappear. And as I cut that away and I go further and further down, obviously the cut is getting larger and larger. But if I go to the 3D view now, what you'll actually notice is the shape that is made by that kind of cutting plane, we've kind of got this exposed area here, this cut surface, okay? That cut surface there, the shape that it actually generates is what's known as an ellipse, okay? So you can see here, if I bring the cutting plane away, the ellipse gets smaller, and if I bring it further down, the ellipse is going to get larger, okay. So that often depends then obviously on the size of the ellipse that we want to create, but essentially an ellipse is when you cut a cone at an angle, okay, the angle cannot be parallel to the edge of the cone. It has to just be an angle that is not parallel to the edge of the cone, okay, and that's where we get the ellipse from. So as you can see there, the ellipse is generated, and it can be a larger one or a smaller one, okay, and obviously it grows larger the further we travel down along the cone, okay. So that's the ellipse shape we have there, and what we're going to be learning about in this video is constructing an ellipse using the auxiliary circles method. Okay, so we'll move to that there now. Right guys, so based on that SolidWorks video there, what we're going to be learning about is constructing an ellipse using the auxiliary circles method, okay? This is the method that is most commonly used for drawing an ellipse in junior cycle graphics. So what we would often be given is, in an ellipse question, you would be told construct an ellipse given the major axis, which are telling us the diameter of that is 160 millimeters long, and the minor axis, okay, which is 80 millimeters long. So what that means essentially is, if the major axis is 160 millimeters long, our radius is 80. So that's the important thing to take away from there. So the major axis overall length is 160, half of 160 for the radius is going to be 80. Okay. The minor axis diameter is 80 millimeters. Therefore, what's to take away from that is that the radius is 40. Okay. Now, sometimes in questions they might say that the semi-major axis, okay, or half the major axis is 80, then you just take it as it is 80 or so forth. But if they tell you the overall length is 160, you divide it in two to get the radius. Now, as you can see here, I've already kind of got my axes drawn in. I have a long line here, which is the major axis, which is 160 millimeters long, just to show you that there. From end to end, here to here is 160 millimeters, and then I've got the short line which is going vertical, which is the minor axis, which is 80 millimeters long, and just to show you that there, that is also 80 millimeters long there. So what I've actually drawn in here is my major axis. I'll write that in there. I'm just going to write in major. Okay, so this line here is my major, and this one here is my minor. Now, usually what you do with the major and the minor axis is you put in what's known as your major and minor auxiliary circles. Okay, so with this as my center point, and out here to my major axis radius, which is going to be 80 millimeters, which we worked out here. The distance from here to here is 80. I'm going to draw in my major circle, or my major auxiliary circle. Okay, there we have our major auxiliary circle. I am also going to draw in my minor auxiliary circle. So just putting that in there now as well. I'd go through my major writing, but it doesn't matter. Okay, so what you can see is we've actually got two concentric circles here. We've obviously got the minor circle and the major circle. So once again, going to write these in. Okay, so that's your major circle right there. And then this guy is your minor circle. So I'm going to write that up here. Okay, and what's important to note is that the major axis, on either end of the major axis, that is 2 points on our ellipse. So we've got a point here and a point here. And what's also important to note is it's the exact same for the minor axis. At either end of the minor axis, we have a point here and a point here. And essentially what's going to happen is our ellipse is going to take this shape, like this. Okay, what we have to do though is we have to find points in between to be able to construct our ellipse. Okay, now you might ask, obviously there's a minor axis contained within here, but the direction of the minor axis is that it's perpendicular to the direction of the major axis. Okay, now the method for constructing an ellipse using the auxiliary circles method is, first of all, as I said, you always have to be given the major axis and the minor axis. Okay, so whatever they are, then you construct your major and minor auxiliary circles, and then the method after that is you are going to divide up our circles into 30, 60 degrees. So 30 degrees through the center this direction, 30 degrees the opposite direction, and then 60 degrees through the center, and then finally 60 degrees in this direction. Okay, and what you'll notice is we kind of have our circle split up into kind of 12 portions. Okay, I'm not going to extend this line up and below because I don't need points up here. Okay, so the method after this now is, and this is very, very important to note, okay, is where I'm just going to use this line as an example to start off with. Okay, so this line right here, and as we can see, that is cutting the major auxiliary circle here, and it's cutting the minor auxiliary circle here. Okay, what's important to note is where it cuts the minor auxiliary circle here, we go parallel to the major axis. Where it cuts the minor circle, you go parallel to the major axis. So where it cuts the minor, I know my major axis is going in this direction, so where it cuts the minor, I'm going to go parallel to the major. So that line there and that line are parallel. Where the same line is cutting the major circle, I'm going to go parallel to the minor axis. So at this point here, I'm going to go down. And what we have found there now, where the two lines cross there, this gives us a point on our elliptical curve. Okay, so let's apply that method again, only we're going to do it for a different line. So for this line here, where it cuts the minor circle, you go parallel to the major axis. Where it cuts the major circle, you go parallel to the minor axis. That gives us another point. Okay, now what we're also going to do is we're going to do the same on the opposite side. So you can see how the curve is going to flow. So we're going to do the exact same on the opposite side. Okay, so we'll just do two in the one go this time. So where it cuts the minor circle parallel to the major axis, which is going in this direction, only this time we're going to the right. Okay, where it cuts the major circle, go parallel to the minor axis. So parallel to the major axis, and we can see where it cuts the minor circle here, parallel to the major axis. And obviously you bring it over far enough that where you're going to project your point down. Where it goes to the major circle, parallel to the minor axis. Where it goes to the major circle, parallel to the minor axis. And that has helped us locate 2 further points. Okay, and as you can see there, we have a series of points now that are going to help us draw the top half of our ellipse. But we also have the bottom half to find. So now we're going to actually do it for all the points on the bottom half in one go. Okay, so at this point here, we are going to go where it's cutting the minor auxiliary circle. We're going to go parallel to the major axis. Cuts the minor circle parallel to the major axis. And what you notice is this point here and this point here should be on the same line because I divided them up into 30 degrees. So I'll go parallel to the major axis this way to the left and parallel to the major axis this way to the right. I will do the same with this point and this point because they should be on the same line. Parallel to the major axis to the left and parallel to the major axis to the right. Just put that one in there again, a little bit heavier. And now I've done all my ones parallel to the major. Now I'm going to do my points parallel to the minor. So where it hits the major circle, parallel to the minor axis. So I'm just projecting up vertically. Where it hits the major circle, parallel to the minor axis. Same over here. And finally, the same here. And what that has helped us do is locate all my points on the bottom half of the curve. And as you can see now, we have a series of points that we have to connect up to draw in our ellipse. So I'm quickly going to speed up the video there while I draw in that portion. Okay. So there you have it, guys. That there is how you construct an ellipse using the auxiliary circles method. Once again, just a little bit of a recap. First of all, given the major axis, okay, whatever the full length of the major is, half of that is your radius for the major circle, and the exact same for the minor axis. Okay, so once again, half of that. So what you start off with is by plotting your major axis and your minor axis perpendicular to it, and draw in your major and your minor auxiliary circles. And then the next step, through the center, what you're going to do is you're going to split up your circle into 30, 60 degrees, okay? And all of those lines where they cut the major and minor circles, they are going to help us locate our points. So if we just take the very first one, like we did for an example there. So this line here that was cutting through both circles at 30 degrees, it cut through the minor circle here and the major circle here. Where it cuts the minor circle, you go parallel to the major axis, which was here. And where it cuts the major circle, you go parallel to the minor axis. And that helps us to locate a point. Likewise with this line. Where it cuts the minor circle, parallel to the major axis. Where it cuts the major circle, parallel to the minor axis. Okay? And you do that for all the points the whole way around. And obviously you can see then it's just inverted on the opposite side. Go parallel, and then this one we projected up, whereas up in the top half we projected down. Projected up, projected down. Okay, but what's important to note is where it goes to the minor circle, you go parallel to the major axis. Where it goes to the major circle, you go parallel to the minor axis. Once again, guys, hope you found that helpful. That is constructing an ellipse using the auxiliary circles method.